Good morning, everyone. Good morning. Hope all is well.
Good morning.
Hey, how's it going? All right. So let's go ahead and get into chapter 3. Had a long weekend, so you guys had a great one and a great holiday. So let's go ahead and get in there. All right. So we're looking at 3.1 measures of central tendency. Starting off with the mean. This green statement over here is not for you. It's for my 155 class. Didn't have room, so I just wrote it over there. So just do the black and the red. So we're looking at the mean, which is another word for average. So the way you would calculate the average is the same way you would calculate the mean. Just that in statistics, they call the average the mean. So you would add up all your data values and divide by the number of data values. So in red, we have a little example of doing that. If we have the data set of 1, 2, 3, 4, 5, and we want to find the mean of the data set, we'll add up 1, 2, 3, 4, 5, and divide by 5 because we have 5 data values. So that would be 15 over 5, and that means our average would be 3. Or in other words, our mean would be 3. All right, everybody okay? If I scroll up too far and you're still copying, of course, let me know. All right, next one is the median, or you can think about middle. It's the middle value. So the first step when calculating the median is that you have to list your data values from least to greatest. You have to ensure that your data set is listed from least to greatest. A lot of people make that mistake first, in which they don't do that. So make sure you don't forget that you have to list your data values from least to greatest before you go to find or establish what your median is. So from there, if the number of data values is odd, you would just take the middle value. That would be your median. If the number of data values is even, then you would take the mean of the two middle values. Because if it's even, then of course there is no legit middle number. So you would take the two middle values, add them together, and divide by 2. All right, scrolling up. So I'm going to give you 2 different data sets for this example. One to show what will happen in the second step. One to show what will happen in the third step. So the first data set, let's say if we have the numbers 1, 2, 3, 4, 5, then our middle value would be the 3 because we have an odd number of data values. All right. Then if we have the data set of 1, 2, 3, 4, 5, 6, then what we would do is we would take the two middle values, 3 and 4, because we have an even number of data values, so there's not a legit middle number. So you take the two middle values, 3 and 4, add them together and divide by 2, and that'll be 3.5. And so what that does, it creates a number that's right in the middle. And so that's what I was doing there. Any questions? Any questions? All right, the green statement, the median separates the data set into halves. So that's what our median is, the middle value. So it separates your data set into halves. Don't have to worry about this orange statement over here. It's my 155 class once again. So they just have other statements that their book holds them accountable for that your book doesn't. So. All right. Next one, the mode. You can think about most. When you think about the mode, it's the data value that appears the most frequently. It is possible to not have a mode. It's also possible to have more than one mode. All right. Bimodal is if you have two modes, and multimodal when you have more than two. So those are for large, large data sets. All right, everybody good? So we have this data set of 1, 2, 7, 8, 9, 6, 7, 5, 2, 9, 7, 6, 5, 1, 3, 4, 7. Our mode would be 7 because it appears the most times. Any problems, any problems? All right, so this is. Yep. This is the mode. That's all you got to do is find the one that appears the most frequently. Yep, that is the mode. Mhm. All right, we good with that? Can I scroll up? Everybody good? Oh, you're fine. You're fine, sir. Okay, so next statement, a summary of data is said to be resistant if outliers, and if you went through your definitions already, and I think we talked about it last week as well, outliers are very extreme values, very, very large or very, very small in comparison to your data set. So if outliers to the data set do not affect it. We got an example of what that means in a second. We're giving you a chance to write it out. So a summary of data is said to be resistant if outliers do not affect it. All right, so let's say if we first have the data set 1, 2, 3, 4, 5, we've already seen those set of numbers already. The mean would be 3 and the median would be 3. We already established that going through the mean and median. But now we're going to compare it to the next data set. So let's say if we have 1, 2, 3, 4, 500. So 500 would be considered an outlier in comparison to 1, 2, 3, 4. To find the mean, add the data values up and divide by 5. That gives us 510 over 5, which is 102. But our median is still going to be 3. Because remember, your median is just your middle value. And the position of 3 in reference to the data set does not change. All right. So this means the median is resistant to outliers because the median didn't change and the presence of the outlier didn't affect it. So last statement out of 3.1, it is a good choice for a measure of center if the data contains outliers. So we talk about the mean. All right, questions on anything before we go to 3.2? All right. Everybody good? Scrolling up. Yes, I will always record the lectures and I'll send them to you guys. Yep. Not a problem, not a problem. So 3.2, measures of dispersion. So dispersion is the degree to which the data is spread out or dispersed. So the range is the first thing that they ask us to find or tell us how to find. That's the distance spanned by the entire data set. And it's the largest data value minus the smallest data value. So if we have that data set of 1, 2, 3, 4, 5, we would do 5 minus 1, and that'll be 4. All right. Standard deviation. So it measures how far a data value is from the mean. And your variance is the standard deviation squared. And it's just another way to measure the spread of the data. So I need some of the red, right? Now, do you need to go past the red? That's all the red right there. That's blue and that's red. Okay, cool. All right, we good to go. Go straight. Can move past standard deviation. All right. So now when it comes to standard deviation, excuse me, standard deviation and your variance, there is a formula for it. We're not holding you responsible. Well, this book really doesn't hold you responsible for the formula and knowing how to use it properly. If there's something that you want to learn outside of class, we could sit down and talk about it. But I'm not going to hold the class responsible for it either. So your assignment when it comes to the variance and the standard deviation is to find an app, calculator website, or something of that nature that will help you calculate both of them. I'll show you one in a second and how it works. But whatever you use, I'm not asking you to buy anything. If you decide to purchase an app, that's up to you, but there's a bunch of free stuff, free apps, free website, like I'm about to show you in a second, that will help you do this. So I'm not asking you to spend any money. And if you're doing more than just typing in the data values and hitting enter, you're doing too much. So whatever you're doing, all you want to do is be able to type in the data values, hit enter, and then move on to the next thing. All right, are we done with copy and variance? Very good. All right, so just give you an example that you can use in order to test your whatever app, calculator website that you have. So one I always use is easycalculation.com. And so that's what I'm about to go to in a second. I'm letting you calculate, copy this real quick before I switch pages. All right, has everybody copied? Can I go to the next page? Very good, everybody good? All right, so what I would normally type in is standard deviation, easy calculation. So once again, you don't have to use this website. It's up to you what you want to use. But to get to easycalculation.com, because easycalculation.com, if you just go to that website, has a lot of different options. So if you just want to go to the standard deviation option, if you Google standard deviation easy calculation, the first option should be that. All right, so notice the directions. Enter all numbers separated by a comma. So, and always pay attention to directions. Some say separated by space, some say semicolon. So it just depends on your app, website, or calculator that you're using. This one or this website asks us to separate it by a comma. So that's 62, 88, 77, 68. So just typing in the data values and hitting enter or hitting calculate. And there you go. So that's 62, 88, 77, 68. Yep. So MathLab, of course, will let you know how many data values. Hope this website is easy. Oh yeah, just follow directions. It's easy. So all you just type in data values and hit calculate. Make sure you use a comma in between like it tells you to. Yep. And if you have any problems with it or questions about it, always feel free to let me know. But MathLab will let you know how many decimals to round out. Also notice that this is down here, you have the population standard deviation and the population variance. So that means this would be the sample standard deviation and the sample variance. So, if you only have 4 data values, then more than likely that's a sample. So, your population, let's take TCC for an example. The student body, the whole student body for all campuses would be TCC student population. This class is a sample of that. So it's just how it sounds. The population is a large body, and then this is a sample of that. So if you only have 4 data values, more than likely you're dealing with a sample. All right. Questions on that? Questions on using this website? Questions on what I'm asking of you as far as standard deviation and variance are concerned? Once again, you don't have to know the formula or use the formula. I'm not holding you responsible for it, but I am holding you responsible for having something that's reliable that will calculate it for you. Yep. Yeah, it's okay to use. All right. So one last thing before we leave this section, I'm trying to check on something real quick. Yeah, okay. All right. Yeah, we got plenty of time. Okay, so notation. So X is always going to represent your data value, no matter what, whether you're dealing with the sample or the population. What happens in statistics is that they're going to start using symbols that will dictate whether you're dealing with the sample versus the population. And by these symbols, they will expect you to know what's going on. So they will give you symbols and not make statements. And they expect, because they gave you these symbols, that the statement has been made that we're dealing with the population or we're dealing with the sample. So your X is going to be your data value no matter what you're dealing with. Now, Greek letter mu kind of looks like a U with a long stem on the left. Greek letter mu is your population mean. So if you see that, that lets you know you're dealing with the population. Lowercase sigma, Greek letter sigma, is your population standard deviation. And then if you square that, that's your population variance. You don't need that if you're talking about this right here. You don't need that. That was the formula. Somebody asked about it in another class. So are you talking about S equal to 11.3, S squared equal to 127.69? All right. Let's go to yeah, not a problem. Oh, also over here on the right, capital letter sigma. Some of you may have seen capital sigma before, whether it's Greek or whatever, fraternities or whatever. That represents the summation. So if you wanted to add up your data values, that's capital sigma. But lowercase sigma is a part of your notation as far as your population is concerned. Then capital N is your population size. All right. Scrolling up some. Yep. Well, capital sigma, most definitely. Yep. Fraternities. Yep. All right. So your sample notation, X bar, X with the bar over it, is your sample mean. So anytime you see a letter with the bar over it, it's just that letter bar. So that's what I was doing over here in this purple circle. Y bar, A bar, that's just another way to have different set of notation. We only have 26 letters of the alphabet. So that's why they start putting on Greek letters, using symbols like the bar and everything like that. Lowercase s is the sample standard deviation, and S squared is the sample variance. And lowercase n is your sample size. All right. Got one more topic to discuss in 3.2. Would you give you guys a chance to write that out? Is everybody finished? Anybody still copying? All right. Okay. Okay. Cool, cool. All right. So this is the last thing out of 3.2. Okay, great, great, great. All right, so everybody good though before I go into this next thing? I didn't leave anybody behind, everybody straight. Okay. All right, so last thing out of 3.2 is the empirical rule. It says approximately 68% of the data is within one standard deviation of the mean. 95% of the data is within two standard deviations of the mean. And then approximately 99.7% of the data is within three standard deviations of the mean. So we have a little diagram that gives you a visual on that, but we'll get to that after you guys finish writing. Yeah, it says within one SD, standard deviation, within one standard deviation of the mean. And so the second statement is two standard deviations. Third statement is three standard deviations. Oh, no, you're fine. No apologies needed. You're fine. All right, going past the first one. All right, so looking at our diagram, these percentages never change. So these percentages here, they never change. That's a part of your empirical rule. The numbers down bottom will change according to your information that you're given. So we'll look at an example and show you what I mean in a second. But this is a visual for the three statements that were just made. Notice right here, said that the mean, just reemphasize what we just finished talking about as far as notation is concerned. The mean is mu, standard deviation is sigma. So your mean is in the middle. And as you go out, 1 standard deviation, 2 standard deviations, 3 standard deviations, those percentages will be as those three statements gave. So if you go add a standard deviation and subtract 1 standard deviation, that gives us 68% of our data, 34 and 34. Remember we talked about, symmetry, this bell-shaped curve is symmetric about the mean. 50% of your data will be to the right, 50% of your data will be to the left. If you were to add these together, that'd be 50%, same thing over here. And then of course, adding them both together give you 100%. So if you just were to go 1 standard deviation out, that's 68% of your data. If you were to go 2 standard deviations out, that's going to be 95%. So you're talking about 13.5, 34, 34, and 13.5. If you add them together, you get to 95%. And then if you were to go 3 standard deviations out, if you go to the purple line, that would be 99.7% of your data. And then you see the 0.15 and 0.15 on the outsides, at the tails. That's 0.3, which will add up to give you 100%. So that's, let's see if I can make it larger. So that's 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15 for your percentages. And then down here, like I said, your median, not your median, your mean, Greek letter mu, is in the middle. And you add a sigma, subtract the sigma, that's the blue line. Add 2 standard deviations, which is sigma, subtract 2 standard deviations, that's your green line. Then add 3 standard deviations and subtract 3 standard deviations, that's your purple line. All right, anybody still copying it? Anybody still copying? All right. All right, let me know when you finish. And then we'll do an example using this diagram. All right, how are we looking now? Can we scroll up? Oh, no. Okay. All right. So let's do an example with this empirical rule. The mean IQ score of students enrolled at University A is 100, and the standard deviation, once again, is SD, standard deviation is 16.1. So they give us the mean and the standard deviation. The mean is 100, standard deviation is 16.1. DET for me is determine. So determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. Determine the percentage of students who have scores between 67.8 and 132.2. We have one more. I'll give you guys a chance to write this down. And then C, determine the percentage of students who have scores above 132.2. Okay, so scrolling up a little, just gonna establish what was given. So like I mentioned before, our mean is 100, standard deviation is 16.1. Here I was just emphasizing just the symbols again, just to make sure we're okay. You know, if it was the population, we're using mu and sigma. If it was sample, that's why I was writing over here in the blue, then we would use X bar and S. So you really don't need this. I was just, like I said, re-emphasizing notation. Yes, these symbols do not change. Yep, they'll be used throughout the whole class period. Really all the statistics. So let's look at this first question A. Now, I don't really have to do any work to figure out question A. It says determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. So really, if you really want to just get the answer, that's just 99.7%. And we'll get to writing the answer in a second. But before we go there, what I wanted to do was to fill out this chart according to the numbers that we have so you can see how it works. So you see that we have our mean in the middle, and then we have these data values that we need to calculate to the right of it, and then values that we need to calculate to the left of it. So we're going to calculate them in that way. So in the green, I have right side. The way we calculate the data values to the right, we're going to take the mean and add the standard deviation 3 times. So the mean is 100, and we add 16.1 to it 3 times. The first one will give us 116.1. Second one, add 16.1 again, gives you 132.2. Then add standard deviation one more time, gives us 148.3. So that's how you find the 3 data values to the right of your mean. Take the mean and add the standard deviation 3 different times. And these are data values above the mean. So that's what the blue statement is. Anything to the right of the mean will be considered above the mean.
I have a question.
Mhm.
So I don't really understand what you mean by like the left side, right side. Is that like what I know that means like what side are you on, but can you explain what you mean, like what's underneath it?
When we say left side, right side, our mean is in the middle. So we're talking about to the right of the mean and to the left of the mean. So right side of the mean and left side of the mean.
Okay, thank you.
Mhm. All right. And so that's a good segue to the other part. So now we're looking at the left side of the mean. So notice the right side, we added a standard deviation. To find the values to the left side of your mean, you're going to subtract the standard deviation. So our standard deviation,
So
once
pretty
again,
much you just add and then subtract.
say that one more time.
Pretty much you for the right side you add and then for the left side you subtract.
Yep, that's all there is to it.
Okay.
Yep, you got it. So to find the left side, we subtract 16.1 from the mean 3 different times. That'll give us 83.9, 67.8, and then 51.7. All right. Questions on what we did here before we go any further? Make sure we are okay. Yeah, not a problem. So, all right, guys, are finishing up with copy right side, left side. This is the diagram right here. So once again, remember I said those percentages do not change. So 34%, 13.5, 2.35, 0.15, that stays the same. The numbers down bottom are what are the values that will change according to what your information is, according to what your data values are. So notice the mean is in the middle, 100. And then to the right, I got my green numbers, which are 8 adding 16.13 times. And then to the left, my purple numbers, subtracting 16.13 times. Once again, these percentages do not change. They hold true and stay the same regardless as to what numbers are going down bottom. And they all add up to 100%. Mhm. All right. So we already talked about how we're going to calculate or how we refine number one. Remember that was just, if you go back to your statement, it says, according to the empirical rule, what would the percentage of the IQ scores be? Let's see, that's within 3 standard deviations of your mean. You know, me paraphrasing, should be close to that, but the answer would be 99.7. That just comes from that third statement of the empirical rule. So really no calculation there, just 99.7. If they ask you about 2 standard deviations within the mean, it would be what, 95%. If they ask you about 1 standard deviation, then it would have been 68%. Okay. When it comes to B, it says determine percentage of students who have scores between 67.8 and 132.2. So get a brighter color. So 67.8 is right here. 132.2 is right here. So what you would do is add the percentages that are in between those two numbers. And so that's why we have 13.5, 34, 34, and 13.5. Adding those together, give you 95%. So any of these can, you can play around with these and see how much percentage of students would be expected to score within certain scores and all the stuff like that. So, you know, any combination of numbers, they could ask you anything. And all you would do is add the percentages between those two numbers. And then that last one asks us about, you know, percentage of students you expect to score greater than or above 132.2. So 132.2 is right here. So you add the percentages that are to the right of 132.2 because it says above 132.2. So that's why you have 2.35 plus 0.15, which will give you 2.5%. So that's how your empirical rule works. Once again, those percentages are fixed. The numbers at bottom will change according to whatever your mean and standard deviation are. And then from there, depending on the question, that would dictate what numbers you add together as far as your percentages are concerned. All right, questions. All right, everybody good? All right. So that's it for 3.2. So we did 3.1 and 3.2 today. I'm gonna pause right here. Next class we'll do 3.4 and 3.5. There is no 3.3 for your class. And that'll be it for chapter 3. All right, so make sure you stay on top of this stuff, guys. Any questions, concerns, comments before we close out? That good? All right, if you're still copying or anything, feel free to let me know. Other than that, did I hear somebody unmute?
Yeah, I had a quick question. I know you said most of our assignment, or pretty much all of our assignments are due like the one day before the end of the semester.
Mhm.
But I believe you said like the chapter one and like those chapter definitions were due like on a specific date. Do you know, have you decided what date those will be? Or released for chapter one?
You talking about just the definitions?
Yes.
Oh yeah, that date is past. I think we said I thought we said it was past. Might be this week. It doesn't matter. If you get them to me, I'm not gonna, because it's like the first assignment. So if you get them to me, I'll just take them. It's fine.
Okay, thank you.
They were due today.
It was today? Okay. Okay. Because I have two different classes and I know one is past and the other one isn't. So whatever I told you guys. So somebody said it was today. So as long as you get it to me in a timely fashion, whether it's, within today, tomorrow, something like that, it's fine.
Okay, thank you. I appreciate it.
No problem. Thank you for the catch. Whoever said that, I appreciate it.
And for the definitions, I know those were due today, but did you mention, like, do we have something else to do too? Or is like,
you broke up in the middle of your statement. Can you say that one more time?
here, I'll type it because my internet's bad.
Oh, okay. No problem.
Hello.
Hey, sir.
So I wasn't sure on quizzes. Do I go to I wasn't sure where to go on quizzes. Like, do we go to the quizzes and test? And then I do believe quizzes are unlimited attempts, if I'm not.
All right, so let me do this real quick because
Okay.
I may have to show you, but probably easier to explain. So let me answer the questions that are just in here that are easy to answer, and then I'll go and show you in Math Lab.
Complete.
All right, so let's see. We have some questions in here. Definitions, you just email them to me. So you can either take a picture with your smart device and email them to me, or just use the Word document and type them out and email them to me as a Word document. So that's fine. Let's see, assignment 1 to a Math Lab. I'm not sure I'm gonna do them yet. So don't do those assignments. If you're talking about assignments that are on the side panel, don't do those yet. I'll let you know. Let's see, is there anything else?
So I meant for the definitions, like the chapter 1 and 2 definitions.
Okay, that's what it was.
Both those are okay.
Yeah. I thought, because we have, if you look at Math Lab, there's a panel on the panel that says assignment 1, 2, and stuff like that. Thought you were referring to those.
Sorry.
Oh no, you're fine. You're fine. And so, is there anything else besides definitions due today? Nope. Just the definitions. And clarify chapter 1 and 2. Yep, just chapter 1 and 2. All right. Did I get everybody before I go to Math Lab to make sure he's clear? Everybody good? Okay. So anybody still copying before I switch the page? Everybody good? Okay. Let's go to Math Lab real quick. Oh no, not me. All right, you had a question about your assignments.
Yeah, I do.
You was talking about quizzes and tests.
Yeah.
So all you have right now are these 2 tests.
Oh, okay. And then test 1 and test 2, and they're all on my Math Lab online. Okay. And then, like, where do I go to take my quizzes? Like,
No quizzes.
wait, what?
Just
Really?
homework and tests.
Oh, so there's no. I was confused about that because usually my previous class, homework, quizzes, and test, but in here in Tidewater, just homework and tests.
Oh, that's not a Tidewater thing. That's a me thing. So you may go to, no, you're fine. But you may go to another teacher and they may have quizzes. You know what I'm saying? So that's academic freedom that the instructor
I
has.
just want to ask you to double check and to clarify things. And
You're fine.
every professor is different about
Right.
their rules and policies.
Mhm.
Okay, but homework and tests then, and then like for as usual for tests, just write down our work, take
Mhm.
picture, and then email our work to you.
Yep.
Okay, as long as it's legible to read, it should be okay.
Oh yeah,
Like
that's fine.
read it, and
Mhm.
it doesn't. Another question regarding taking tests.
Mhm.
Do you know how I have this concern when I take pictures, right, of my work and send it
Mhm.
to you. And then I thought, what if you cannot read them in like pencil writing? Like
Mm.
I was about to either previously the previous instructor I had said write it in blue or black ink pen.
Mhm.
Is it okay if you still cannot read it for some strange reason, but is it okay if I still write down my work in blue or black ink pen?
Yeah, I mean, if there's an issue, I'll let you know, but it should be fine.
Yeah. Like just let me know if there's any issues or if it's hard for you to read. If it's
Mhm.
that's my point. That's what I wanted to ask.
Okay, yep, not a problem at all.
And
All
then
right, take care, sir. Take care.
crap. Oh man. I think